All right, let's dive into a really big question in medicine. How do we really know if the care someone's getting is, well, great? You might think it's as simple as whether the patient gets better, but it turns out the answer is a whole lot more complex than that.
I mean, think about it. Imagine a patient goes through some super complex treatment, and they walk out of the hospital totally healthy. That's a success, right? Well, yeah, but that's not the whole story. The real question, the one we need to ask is, was that actually great care? Or did they just get lucky? And this is really where we get to the core of it. A good outcome, well, that's pretty straightforward, right? The patient is healthy. But good care is all about the process. And here's the critical distinction. You can actually have a good outcome even with pretty bad care. And on the flip side, and this is the tough part, sometimes even the absolute best care in the world can't prevent a poor outcome. That's exactly why we have to focus on measuring the process itself to make sure it's solid, repeatable, and reliable every single time.
Okay, so that brings us to our first big idea here, success beyond survival. It's all about finding a way to look past just that final result and really dig into the entire system of care.
So, how do we know if a treatment is truly working as well as it should? You know, this is a huge challenge for any top-tier medical program. It's just not good enough to say, hey, most of our patients do well. You've got to have a systematic, evidence-based way to measure quality, to hunt down those hidden flaws, and to just keep getting better. And the solution to that challenge has a name. It's called outcome analysis. The best way to think about it is like clinical detective work happening behind the scenes. It's this formal process where you look at the results, not just to see who got better, but to figure out how well the entire system, the structure, the process, all of it is actually working. So how do these clinical detectives actually do their job? Well, they don't just wander around looking for random clues. They use a proven, really powerful framework for quality. And that framework is called the PDCA cycle. It sounds technical, but it's actually pretty straightforward. First, you plan. You decide exactly what you're going to analyze. Then you do it. You go out and gather all the data. Next, you check. You double-check your work, make sure the analysis is right, and then comes the most important part. You act. You take what you've learned and use it to make real improvements. It's this continuous loop, always aiming to get better and better.
All right, section 3, gathering the vital clues. Because to make that whole PDCA cycle work, you absolutely need good data. In the world of outcome analysis, these data points are the clues that tell you what's really happening.
So, what are these clues? Well, they're often called key performance indicators, or KPIs. We're talking about things like survival rates at that critical 100-day mark after a procedure, or how quickly a patient's blood counts recover. That's called time to engraftment. They track infection rates from things like central catheters, and even look at patient complaints and incident reports. Literally, every single piece of data is a potential clue. And here's where the detective work gets really interesting. Take a look at this chart. It's tracking mortality within that 100-day window, and you can see a pretty clear pattern, can't you? In both 2017 and 2018, there's this noticeable spike in February. Now, if you're an analyst, this is a huge red flag. It's a major clue that you absolutely have to investigate. So what do you think? Looking at this data, does it mean that February is just a dangerous month for this kind of treatment? I mean, it's tempting to jump to that conclusion, isn't it? But not so fast. This is a classic trap. Jumping to that conclusion would be a big mistake. A single clue, a single chart, almost never solves the case. Because, and this is so important, correlation is not causation. Those spikes in February, they could be a total coincidence, or they could be caused by some other hidden factor. Maybe sicker patients tend to get treated in the winter months, or maybe the staffing is different. You have to do a much deeper dive to find the real root cause. And finding that root cause, well, that leads us to the most important part of this whole cycle. Section 4, from data to action. It's about turning all this analysis into something real. Because this is where all the analysis actually starts to mean something. The goal isn't just to write a bunch of reports that are going to sit on a shelf and gather dust. No way. It's about driving real, tangible changes that improve patient care and literally save lives. It's all about putting the A, the act, into that PDCA cycle.
So what does that action look like in the real world? Well, based on what they find, a team might develop all new patient guides that are easier to understand. They might improve staff training and how they assess competency. Or maybe they realize they need to revalidate a critical piece of medical equipment. They could even end up changing the forms used to clear donors, or completely update their standard operating procedures. Every single one of these changes comes directly from that detective work.
And you know, this constant cycle of improvement has this huge ripple effect. It's not just about today's treatments, it really shapes the entire future of medicine.
There's a quote that really captures this idea perfectly. It says, as each new development comes into implementation, a new set of outcome analysis needs to be developed. Basically, what that means is the work is never, ever done. As science moves forward, you have to reinvent this whole analytical process for every single new thing that comes along.
And this isn't just some theory either. This exact same rigorous process is being used right now to validate and improve some of the most novel therapies out there, like CAR-T. It's the framework that makes sure that the incredible, groundbreaking treatments of tomorrow are as safe and effective as they can possibly be.
So, we'll leave you with this final thought. This whole cycle, plan, do, check, act, is this powerful engine for improvement that makes medicine better, safer, and more effective. It works. The question is, where else could it improve our world? Where else in our lives, in our work, could we apply this same systematic approach to get seriously better results?